Let's start building our vocabulary that we are going to use in this course. And first of all, let's talk about two probably most important definitions. It's objects, individuals, and variables. Let me remind you the task. So we have 5 apples. We found out that every apple has different amount of sugar. In this particular example, we investigate apples. We measure concentration of sugar, and concentration of sugar varies from apple to apple. So in this case, apples, these 5 apples, 5 individual apples, are objects. It's what we investigate. And the concentration of sugar, it's a characteristic or it's a property of these objects that we actually measure or investigate. And then you know that this characteristic, it's not constant. So it varies from one apple to another apple. So therefore, this characteristic we will call a variable. So variable is a characteristic of interest that varies. The next important definition, it's a sample. What is a sample? I mean, in chemistry or in physics, usually sample is a synonym for object, right? But in statistics, we have a specific meaning for this word sample. So sample, it's a collection of individual objects that you work with. And sample, it can be collection of indeed physical objects, like for example, collection of apples, but it also can be a collection of, for example, experiments that you run. It can be a collection of phenomena that you investigate and many, many other things. So therefore, in addition to objects, we will sometimes use a more general word, individual. So individual, it's a part of your sample that you work with. And sample, it's a collection of individuals. Sample has a size. It's just the number of individuals in the sample. And in our case, sample size is 5. It's very important that when you collect your sample, your individuals are collected independently. Independent in this case, you can consider as just when you collect the first apple, it doesn't influence where you take for example, pick the second apple from. So they are completely independent. And we will talk more about what is independent sample, what is random sample, and other properties of sample a little bit later. Then this is the measurements. So all these numbers are measurements, or sometimes it can be also observations. This is another example. In this case, we have a relatively small sample. We have a sample consisting of 2 individuals, 2 objects in this case, 2 plums. And then you can see various characteristics that we measure and that vary from one plant to another plum. So you can see, for example, we have sugar content, which is apparently a measurement. We have a color, which is more observation than a measurement because you cannot measure it in this qualitative way like dark red fruit. You have mass in grams, you have a diameter in 45 millimeters. So all these are variables because they are not constant. They vary from one plum to another. Okay. So we can actually define a variable in a more general way. So we know already that variable, it's a property, it's a characteristic of your individuals that vary, but it can vary in different ways. First of all, of course, and that's what we observe most of the time, it varies from one individual to another individual, but it can also vary from the same individual, but in time. For example, if you measure sugar content of apple, which is stored for a long period of time, you will find out that actually it also varies, it develops somehow, and that's also a variable, right? So in this case, it's a specific type of variable which is called time series. Also, when you do the measurements, you either measure one property at the time, and that's most of the sensors that you use for your experimental work, they actually do this. They measure one particular property at time, and that's what we call a univariate measurement. So we measure one variable. But nowadays, modern analytical equipment can also let you do the multivariate measurements. For example, spectroscopic equipment like infrared spectroscopy, where you measure how much of light is absorbed or reflected, you do this not just for one particular wavelength. You do this for many wavelengths. And therefore, the typical spectrum consists of hundreds, sometimes thousands of values, absorbance, for example, in case of infrared spectroscopy, absorbance of light at different wavelengths. So in this case, we talk about multivariate measurements. Statistics mostly deals with univariate measurements, so we will actually, in this course, we will consider mostly univariate measurements, although we may have different variables, for example, 5 variables together and so on. But if you have multivariate data sets, like, for example, spectroscopic data set, then you need to use specific methods for multivariate data analysis, which is beyond the scope of this course. So coming back to our example, now we know a lot of definitions, but as I said, it's not always we deal with individual objects. Sometimes we also deal with phenomena or maybe experiments. And in this case, we will use another word. It's called run. So run, it's execution of experiment with a fixed parameters of this experiment. So in this case, you can see I have a very simple experiment. I have 3 simple experiments where I prepare a popcorn. So I simply use a microwave oven and corns, and then I just run the micro for a period of time and prepare a popcorn. So you can see that I have 3 runs. It's my 3 individuals. It's 3 different outcomes. It's a synonym of objects. So if we had a physical objects, in this case, it would be 3 objects. So my sample size is 3. And then you can see that I have 5 different variables. And you can notice that some of them look like blue, some of them look like red. And you probably understand why, right? So for example, time and power and amount of salt, it's something that we add. So we define the values for these variables. Also, they vary. They are not constant, you can see, but it's we who define them. While taste, for example, we can ask our friends to grade the quality of popcorn between 0 and 10, and then we can compute average grade. So that will be our taste. And also you can, for example, observe the color of the popcorn, like white, beige, brown, and so on and so forth. In this case, it's also variables. It's also characteristics of the product. But in this case, it's a measurable characteristic, so we cannot define them directly. Nevertheless, all these 5 are variables. So we have a data with 3 runs, 3 individuals. So our sample size is 3. And for every individual, we have 5 different variables. So this combination of individuals and variables, we will call a data set. So that's the most common representation of data set. It looks like a table, or in case if all values in your table are numeric, you can also call it a matrix. And then every row of this table, it's an individual. It's either an object or experimental run. And every column of this table, it's a particular variable that you measure or set. So it's this representation sometimes is called flat table representation or tidy data representation. And try to make sure that all your data set is represented like this. So every variable is a separate column and every individual is a separate row. That's what we actually will use in this course. And in the next video, we will talk a little bit more about the variables.